Hey guys, we are continuing with our at-home learning. You guys are doing awesome with this. And right now, we're going to go over how to do homework 10.4. So by the time we're done with this, you're going to have almost the whole thing done. That's what's awesome here. So stick with me, make sure you watch the whole video, and have your homework printed and ready. So you want to have this one right here printed off the canvas so that you can follow along and fill it in with me. So here we go. Homework 10.4 talks about this circle right here. Okay, this is called the unit circle. We're going to talk more about why that is, but right now we're going to focus in on how to fill in the degrees going around the circle right here. Okay, so take a look right now and see this side right here, this angle. Okay, this side right here is called the initial side. That is where we begin. That is considered 0. This is the beginning, so this is 0 degrees right here. I haven't even begun my angle. I start here, and what do? I rotate up and around the circle. That's what happens with an angle on the unit circle. So I start at 0. Okay, so take a look if I divide the circle into 4. So it'd be like taking a pizza, take your pizza cutter, and you cut it into 4 equal pieces. Okay, well, most of you know how many degrees is in a whole circle. Like say you jump and you do what? You do a 360 if you do a full circle. So all the way around the circle, from here all the way around, is 360 degrees. Well, if I know that, and I've split this into 4 equal pieces, how much is each piece worth? We'll take 360, divide it by 4, and each piece is worth 90 degrees. You guys know, you can see that right angle, that from here to here is 90 degrees. So what if I go from 90 and then I go another 90? Well, I just use addition. 90 plus 90 is 180. Well, what if I go another 90? You're right, we're up to 270. If I go another 90, there we are. That's 360 degrees. So starting out, just take this piece by piece, like you're cutting up a pizza. Right now we've cut it into 4 equal pieces and fill in those degrees. Okay, now I'm going to take my pizza cutter, and what am I going to do? I'm going to slice it again. This time I'm going to cut it diagonally right down the middle. So I cut this direction and this direction. So if you look at both the blue and the yellow lines, how many pieces have I cut this into? 1, 2, 3, 4, 5, 6, 7, 8 pieces. My pizza is now cut into 8 pieces. Or you could just look at this section and say, well, this 90 degrees has been cut what? Into 2 pieces. If you take 90 and cut into 2 pieces, how much is each piece? Each one is 45 degrees. Do you see that? Each one of those is 45 degrees. So I can go through and label my degrees based off this. Okay? So that means from here to here was 45. And then I add another 45 degree piece and I'm up to 90. We're just using addition here. Now what happens if I take 90 and add 45? I'm going to end up with 135. If I take 135 and I add another 45, you got it, we're at 180 that I already have filled in. And then I add another 45 degree piece, and right here I'm up to 225. I add another 45, and now I'm up to 270. I add another 45, and I'm up to 315. And then I add another 45, and I'm right back to 360. All we're doing is we're adding 45. We're adding these pieces, okay, all the way around the circle. Okay, now you're going to take your pizza cutter and you're slicing your pizza. Now, this is the trick. You now have to ignore the blue lines. I know it's kind of hard because they're there, but ignore the blue lines. Pretend they're not there and focus solely on my green pieces, okay? Ignore the blue, and now you're going to focus on the green. Can you see the green pieces? I know it gets pretty colorful at this point. Focus in on the green. That means right here in this 90 degree spot, okay, so let's take this, just this 90 degree spot, and look at the green pieces. How many pieces did I cut just this section into? Well, there's 1, there's 2, there's 3. Can you see the green pieces? I've cut this into 3 equal pieces. Well, if you take 90 and cut it into 3 equal pieces, each piece is worth how much? 30 degrees. Can you see those pieces? Each one is worth 30 degrees. And so ignoring the blue lines, we can now fill in the rest by saying from here to here was how much? 30 degrees. Now how much do I add more? Another 30, and now I'm up to 60. Now I add another 30, and I'm up to 90. Do you see how we're doing this? Then what? I add another 30 degrees, and right here I'm at 120. I add another 30 degrees, and I'm up to 150. Add another 30 degrees, and looky there, I have it labeled 180. Add another 30. Okay, I'm going to quit using my little piece. I hope we get the pattern. 210. Add another 30, 240. Another 30, 270. That's correct. Add another 30, 300. Add another 30, 330. And another 30, we land at 360. So if you will take this one piece at a time, meaning do the 4 pieces as though cut it into 4s, and then take your pizza cutter and cut it basically in half again, right? Each of those pieces get cut half again. Do all your 45s, and then start all over and cut it with the green and do it in increments of 30, and it's not too hard to fill out the degrees on this unit circle. Okay guys, now that we've filled in the inside part, we're going to learn how to do the outside part. In order to do that, I need to use a few things here. So let me get them ready. Okay guys, in order to teach you the next part, we have to talk about triangles for just a minute. So take a look at these triangles. I would consider these to be what? They're called similar triangles. Similar triangles have what? The same angle degrees, so the angles are the same in each of these triangles, from small, medium to large. They all have the same angle measure, but the sizes, the length of the sides will be different. But no matter what, they will all be proportional to each other. Okay? So, for instance, take a look at these triangles, and they are actually one of our special triangles. These, I've cut them so that they are 45, 45, 90 triangles. So they are 45, 45, 90. Now, if you remember from a previous unit that we can label this one right here, that if this side is 1, then I know the other leg is also 1. 45, 45, 90, the two legs are the same. And the hypotenuse measures square root 2. So if I tell you this particular blue triangle measures 1, 1, and square root 2, what if I tell you the yellow one is exactly twice as big as this one? I actually cut it, watch, so that the length is exactly twice that of the blue one. So if this side was 1 and 1, then that means this one has legs, what, 2 and 2. But what would be the hypotenuse? Well, if it's twice as big, I'm multiplying each of these sides by 2. 1 times 2 makes this. 1 times 2 makes this. Well, what's square root 2 times 2? You got it. It is 2 square root 2. That's how we can get the measure of these sides. They're proportional. We can multiply each of the sides by the same number. Okay, what if I tell you this purple one here is exactly 4 times the blue one? Well, you got it. If these sides were 1 and 1, and this one's 4 times as big, its legs are going to be 4 and 4. So what did I do? I multiplied by 4. I multiplied by 4. And what's square root 2 times 4? It is 4 square root 2. So that's what we mean by the sides stay proportional. I can take these 3 sides and multiply it by the same number in order to get each of these. Okay, so let's go back to my circle. Okay, so I want to go back to my circle and take a look at it for a minute. Okay, I want to be able to use this 45, 45, 90 triangle within my circle with this condition. I want it to fit perfectly in there where the hypotenuse is the radius of my circle. That means this hypotenuse has to go from the center to the outer edge. That's what a radius does, right? Does it fit? Does that length fit? No, it goes past my circle. It's just a little too big. Do you see that? It's just a little too big if I try to put it in there so that the hypotenuse is the radius. Okay, so that's the goal, is I want to change this one and shrink it. I want to make it just a little bit smaller. When I do, I want to create a new triangle, this yellow one. Now watch this yellow one. Look at this. If I line it up, that hypotenuse fits perfectly inside that circle. Do you see if I rotate it around, it stays inside the circle, touching from the origin to the outer perimeter of the circle. It fits perfectly in there. So we're going to use our concept of similar triangles, and what am I going to do? I'm going to shrink this blue triangle into the yellow one. Just like I took the blue and I multiplied To get bigger, how am I going to get smaller? I'm going to use division, right? That's what I want to do. Now, what if I tell you that my circle here has a radius of exactly 1? What would that mean? It means on my yellow triangle, I need this hypotenuse to have a measure of 1. That's my goal. If I can get that to be 1, he now fits on my circle. Okay, well, to get bigger, we multiplied, so you're right, we're going to divide to get smaller. So I need to change square root 2 into 1. So that's the question. What could I divide square root 2 by in order to get the answer to be 1? Well, what would I divide by? Square root 2 divided by what? Divided by square root 2. So do you understand that in order to get from here to here, I have to divide by square root 2? Well, just like in getting bigger, smaller works the same way, that if I divide this side by square root 2, what am I going to have to do to these two sides? We're going to have to divide them by square root 2. So this side becomes 1 divided by square root 2, and this side becomes 1 divided by square root 2. These are similar triangles. Just like these are similar, now my yellow one is a similar triangle, and these are its measurements. 1 over square root 2, and 1 over square root 2. Now, I'm not going to get into the details on this because you don't actually need to know the how, but if we do something called rationalizing the denominator, and I can tell you that 1 over square root 2 is the same value as square root 2 over 2. Is the exact same. 1 over square root 2 is the same value as square root 2 over 2. Now, we could go into a lesson as to how I found that, but like I said, you don't need to worry too much about it for this. All you need to realize is these are the measurements of this triangle that's going to fit exactly on my circle. Okay, so let's now, what I want you to do is, if you notice, the homework had a page 2. Did you print out that page 2? And it's 2 little triangles on there. And one of your triangles looks exactly like this one. So right now I want you to pause the video. I want you to make sure you have those 2 triangles cut out, and then I want you to come back to me. Okay, now that you have your triangles, find the one that looks like mine, that looks like the 45, 45, 90, where the 2 sides are equal. And these are the measurements we want to use, but we want to actually write it on our triangle to make it easy for us to use. So take your pencil and do the hypotenuse as 1, and this leg square root 2 over 2, and this leg square root 2 over 2, so that your triangle now looks like mine. Can you see that? Pause it and make sure you get it to match. Now, we do want to have this triangle be reversible, so we are going to flip it over and write the numbers on the back. The hypotenuse is 1, and this is square root 2 over 2, and this is square root 2 over 2. And make sure yours matches mine. Okay, now that you have that triangle labeled, now we're going to take a look at the other triangle that should have been on your homework that you should have cut out. Now this one is our other special triangle, and it is our 30, 60, 90. Now if you remember from a previous section, from last section, we learned how to label the sides. The short leg is 1, the hypotenuse is 2, and the short leg is square root 3. Now I have the same problem where I want the hypotenuse to fit as my radius on my circle, so I need to change this number into 2. So what do I do to change this into 2? What would I divide by? Well, 2 divided by 2, right? So I'm going to divide all of these numbers by 2. And when I do, 2 divided by 2 becomes 1. 1 divided by 2 becomes 1/2. Square root 3 divided by 2 becomes square root 3 over 2. And those are going to be the values that we use for our 30, 60, 90. And just like the other one, we're going to write it in on our triangle. So take your triangle, make sure you have it turned the same way I do. Make the hypotenuse 1, the short leg 1/2, and the long leg square root 3 over 2. And once again, we want this reversible, so flip it over. Do the same thing over here. Hypotenuse is now over here as 1, the short leg is 1/2, and the long leg is square root 3 over 2. You may need to pause this video to make sure you get all those numbers on there. Okay, now that we have our 2 little triangles that fit onto our circle, how is this going to help us? We are going to learn now how to fill in these going around. Now notice that they have parentheses and a comma in between them. That's an ordered pair, you guys. This is an X and a Y value. Now where do the X and the Y come from? Well, take a look. If I extended this line right here, say I extended it, let's get my yellow. If I extend it further out, do you see that? If it just kept going, this is the x-axis, you guys. That's the x-axis. Can you see that? I feel like that doesn't show up very well. This is the x-axis, okay? And if I were to extend this one up and down forever, say that went forever, okay? That is the y-axis. Can you see this? It goes on forever. I've just drawn this cute little circle on my graphing plane, on my x-y axis. But it's the x-y axis, okay? And these are just ordered pairs. So how do I start? Well, let's take a look at this first one, okay? How do I find this ordered pair? Well, how far over did I go? Now recall, what is the radius of this circle? Remember, I made these triangles so that they would fit in here, and all of them needed to have a radius of 1. Do you remember that? So that means the distance from here to here is exactly 1. So that means my x value is 1 in order to make it to this point right here. And how far did I go up and down? 0. This is the point 1, 0 on the xy axis. Okay, what about this one straight up? Okay, from the origin, which way did I go, left or right? I didn't go at all, so that's 0. Then I go up 1. This is the point what? 0, 1. Okay, what about to the left? On the x-axis, what happens if I go left 1? That's right, it becomes negative 1, and I went up 0. This is right here. This is the point negative 1, 0 on my graphing plane. And what if I go from 0, 0, I go down 1? That's the point 0, negative 1. They're just ordered pairs. They're x, y values. Okay, now how am I going to get the rest of these? Here's where our triangles come into play. Okay, get that first triangle we made. Okay, this one, that's the 45, 45, 90. And here's the trick. This one has to be the radius. It has to match up with one of these lines on here. Okay? It's going to become what we call a reference triangle. Match it up right here with the 45-degree ray. And when we do a reference triangle, this corner has to be at the origin, and this corner of my triangle has to be right here at the 45-degree mark. Now, watch, I could put my triangle this way, couldn't I? Except that a reference triangle is defined that it must connect from the origin to a point on my ray, and it has to be touching the x-axis. This right now is touching the y-axis. That is not a good reference triangle. I have to flip it this direction. It has to be touching the x-axis. Do you see that? So that's the direction we're going to put our triangle. Next, I'm going to fill in this ordered pair right here. Okay, that's the one that matches my 45 degree. Remember, this is an x value and a y value. X goes left and right, y goes up and down. So from the 0, 0, how far do I go to the right, and how far up do I go to make it to this point right here on my circle? Okay, well, what is the distance from here to here? That's the purpose of the triangle. It measures exactly square root 2 over 2. This is like a ruler. My triangle is my ruler. It's measuring for me. That is square root 2 over 2. Okay, now how high up did I go? Again, this is like my ruler. My triangle helps me. It is exactly square root 2 over 2. I can use the measurements of the sides of my triangle to fill that in. Okay, now watch. This triangle is helpful. We're just going to flip it right over. We're going to reflect it and match it up. And where does it match up now? Right here to this point. Do you see here? At 135 degrees, we're going to find its matching ordered pair right here. How am I going to do that? Start from 0, 0. My x value, how far to the right or left do I go? Well, I go left, square root 2 over 2. But on a graphing plane, what do I have to remember if I go to the left? That it's a negative value. So this can be negative square root 2 over 2. And how far up did I go? Square root 2 over 2. Are you seeing a pattern? Okay, now flip it upside down. Take your triangle and flip it upside down. Where does it match up now? Right here. Now just to double check, remind yourself, to be a good reference triangle, one side, one leg has to be touching the x-axis. And the hypotenuse right here has to be 1. And we're good, okay? That's how I know how to position it. Okay, how far do I go left or right? What's my x value? I went left. My number's upside down, but I can still read it. Left, square root 2 over 2, so that's a negative square root 2 over 2. And then I went down square root 2 over 2. Negative, good catch. Down is going to be negative. Okay, we're going to flip it one more time. over to this side. Okay, here we go. How far did I go on the x-axis? Square root 2 over 2. And how far down did I go? I went down square root 2 over 2, but down means negative square root 2 over 2. So notice these four, yes, are going to have the same values, just some are positive, some are negative. Okay, grab that other triangle, grab your 30, 60, 90. We're going to use it. Okay, how could I position this triangle to get this point right here? If I want to find the 30 degrees, see right here? Okay, I have to match up the hypotenuse, the side that's 1, from the origin to that point, right? That has to match up. But, I have to have one of the sides laying on the x-axis. That does not work, does it? Okay, so let's flip it over. What about this way? Now that fits better, doesn't it? One side lies on the x-axis and the hypotenuse is laying on the ray there. Okay, so we're going to do the same thing. How far do I go over? What's my x value? Well, the length of that side is square root 3 over 2. And how far up do I go? 1/2. I'm using the lengths of my triangle, the side measurements, okay? All right, flip it over. Here we go again. All right, how far do I go on the x-axis? Square root 3 over 2, but left, so it's a negative square root 3 over 2. And up, 1/2. Okay, flip it over. Why do I do the flip over? Because it keeps that side against the x-axis, and that's what we got to have in a reference triangle. And this creates the right angle. All right, so when I do my x value, square root 3 over 2, but to the left is negative square root 3 over 2, and down, that's right, negative 1/2. Okay, flip it again. Come over here, and x value, square root 3 over 2, and down means negative 1/2. All right. Uh-oh, I'm out of triangles, you guys, and I haven't done these four. How do I do those? Watch this. I can use this same 30, 60, 90 and just turn it a new way, and ta-da, it fits perfectly in there. One side lies against the x-axis, okay, and my hypotenuse matches up from the origin to the point here. That's what I want. Okay, do the same thing all over again. X value, I went over 1/2, and then I went up square root 3 over 2. And flip my x value, I went left, that's negative 1/2, and up square root 3 over 2. Okay, flip again. I went left, so that's negative 1/2, and I went down, which is negative square root 3 over 2. Okay, last time, you guys, flip it, flip it. Here we go. Okay, I went to the right, positive 1/2, and down, negative square root 3 over 2. All right, ta-da! Using these handy little triangles here, we have now filled in all of those ordered pairs. Okay, now, question is, why did we do that? That's always the big question. Why? Why, Miss Hurst? Why do we have to do this? Okay, this unit circle is so cool. It actually can help us find trigonometric function values, okay? So take a look down here at the bottom of your worksheet. We learned in 10.3 how to use reference triangles to find the values of trig functions, okay? We did, that's what you did in 10.3. The unit circle, that's what this is called, above can be very helpful to find these same values. Watch how cool the unit circle is. Right here, sine of theta is equal to, I'm going to tell you, the y value. Okay, what does that mean? It means, take a look at problem number 2, right here. If I want to find the sine of 300 degrees, well, first, go find 300 degrees on your unit circle. Okay, look around. Where's 300 degrees? Boom, it's right here. So I'm looking right here at this ray, and I'm looking at this ordered pair that goes with it. Do you see that? This is the ordered pair that goes with 300 degrees. Okay, if it wants me to find the sine, and I just told you that using the unit circle, the sine is equal to the y value. Which one of these numbers is the y? Well, in an ordered pair, this is the x, this is the y. So the y value is negative square root 3 over 2. That's the answer. Negative square root 3 over 2. And that's how it works, okay? Cosine. All right, how do I find cosine? If sine was the y value, guess what cosine is? Yep, it is the x value. Okay, so if I want to find cosine of 135, let's do this next problem. Go find 135 degrees on your unit circle. Here it is. Here's its ordered pair right here. See that ordered pair? That's where I'm going to look. Cosine is the x value. Which one of these is the x value? X, then y. So this one's the x value, which is negative square root 2 over 2. And that's my answer. So that's how we find sine and cosine. All you need to do is look at the x and the y value. Okay, now we get to tangent. Tangent's a little trickier. It is actually going to be the y value divided by the x value. We have to divide the two numbers. Okay, so let's try one. Here we go. Tangent of 180. Find 180 degrees. Right there. Okay, here's its ordered pair. So I'm looking right here. This is the x and this is the y. To find tangent tells me take the y and divide it by the x. So the y value is 0 and the x value is negative 1. Anybody know what 0 divided by negative 1 is? Do you remember these cool tricks? Have you ever seen this? The okay and the no. Remember that. What does that mean? If 0 is in the top, that's okay. That's okay. The answer, if 0 is in the top, is just going to be 0. The answer ends up being 0. What if 0 is ever in the denominator? No, we can't have that. What would I write my answer if I had 0 in the denominator? We would write undefined. That would be our answer. If 0 is in the denominator, it is undefined. Okay, so back to here. Let's try another one. Sine of 45. Go find 45 degrees right here. Here's my ordered pair. I'm looking at this one. I'm trying to find sine. Which one do I take for sine? The y. What is my y value? Square root 2 over 2. Okay, cosine 150 degrees. Go find 150. Here it is. Okay, we're looking at this ordered pair right here. Cosine is the x. Which one of these is the x? Right here, x then y. So the x value is negative square root 3 over 2. Not too bad, you guys, right? Okay, this is your homework. I have done everything up to here. Now you go and finish numbers 7 through 11. You go do those problems. When you're done with that, take a picture, upload it to me on Canvas so I can give you credit for your homework 10.4. Nice job, you guys. Keep up the good work. You can do this.